So today I want to talk a little bit about how we can leverage organic materials to create smart but sustainable products and environments. And I think that there's a bit of a tension here between those two, right? Because we can all think about where we want to go, but the reality is right now our landfills are filled with clothes, e-waste, all sorts of plastics, and there's a lot to do there. So how do we bridge this tension? So fast fashion is one example of this, right? Where we have this essentially culture of creating products that are short-lived, right? And we encourage this through small changes very, very quickly, right? Now, what happens, essentially, is that these things end up in landfills like this or in different spaces, right? And they don't break down. So we're not encouraging reduction, we're not encouraging reuse, and we're not recycling these products, right? So instead, I want to think about how we think about end of life and how we might be able to change this. Instead of that, we can potentially create smart products and services that instead of the fabric and the clothes that we have now, we can repurpose them. We can make them intelligent, but they're still sustainable, right? So a shirt or an outfit that you get for your party on the weekend, right? Once you're done using it, you can turn it into a smart running shirt, right? Or your self-heating cup can be thrown into the landfill and decompose, right? So I want to start with where I'm going to show about 3 examples of our intern projects over the summer at Accenture Labs. And I'm going to start with this material here. This is an e-textile that is soft, it's flexible, it's stretchable, and it's conductive. And we can do a lot with this. We can essentially detect airflow, we can detect heat, we can detect stretch and bend, we can use it as a proximity sensor, we can do all sorts of fun things with it. And so once we do that, right, we can take it and we can embed it in a shirt. And in this particular case, what we're using it for is to start to think about how we connect with people abroad. So when you feel like you're missing somebody, you can use this shirt, right, and this material as first a touch sensor. And when that touch sensor is actually interacted with, the person on the other side feels some heat, right? So it can do both of these things. And ultimately, once you're done with it, you can choose to compost it, or you can actually break it down, you can carbonize it, you can pound it into a powder, and then you can repurpose it onto new fabrics. And if we combine this with other technologies, like the sweater that you see here, so this sweater is made, that patch up there is made of something called MXene. MXene essentially, in this particular case, functions as a supercapacitor. So what we can do now is add power to our devices, embedded in the textile, using common oxides and organic compounds. And we can combine this as well with other things that provide energy harvesting. And now we have a self-sustained textile that is fully recyclable, essentially, fully reusable. And so we are designing, essentially, for a circular manufacturing process here. We can also combine them with things like SMAs, right, shape memory alloys, or with thermochromic inks to extend their life, right, to make them more interesting, to give them more functionality so that we don't want to throw them out as quickly. Another example I want to talk about outside of textiles is with self-heating packaging. Now, in this case, what we're doing is we're actually taking years of evolutionary development in plants and leveraging the fractal patterns in leaves. And we use these to create self-heating packaging that uses chitosan, which is a type of shrimp shell, essentially, that uses paper and wax and silver nanowire. And we can create, using wireless conductive charging, we can actually create this packaging that goes up to 70 degrees Celsius. And it can be used to heat your food on the go. It can be used to heat wax strips or anything else. And the nice part about this is that you can actually throw it in your backyard, any dirt, doesn't require an actual industrial composting process, and it fully degrades over 60 days. Finally, I want to talk about actually designing for destruction. So in this particular case, what we're doing is the functionality of the device is in its full destruction. So these are materials that, when heated, break down, when eaten, break down, right, those kinds of things. And the functionality is provided. And so with this, for example, you can capture it, right, and reuse it, recreate it, or you can, and you can take the chips themselves and reuse them. And they can provide all sorts of interesting things, right? So you can, for example, have a sensor that tells you when you've got a leak, a water leak, right? Or when a temperature that is unsafe has been hit, right? Or in this case, what we're doing is creating chocolate that essentially uses backscatter RFID technology to become interactive. And this is fully edible. There is nothing unsafe about it, right? So again, the functionality, right, is in, and this can be used, for example, as your ticket to a concert that you can then eat afterwards. Why not? So this is just an example of a couple of the projects that we've worked on. And the idea here is really taking that sustainability component, leveraging materials in the world that we already have, and being able to create novel applications and use cases with them. And so what could we do with this? Could we create fully degradable insulin pumps, right? Those are short-term use. Can we create batteries that we can compost? What can we create, essentially? And so I'm going to leave you with that. Think about what can we leverage in our world to create fully sustainable, intelligent products and cities. Okay, thank you.